Coordinate proofs classifying quadrilaterals. So first let's take a look at the formulas we're going to use and when we're going to use them. The distance formula we'll use to determine whether sides are congruent or diagonals are congruent. The midpoint formula we can use to determine whether diagonals bisect each other. And slope formula we can use to determine whether opposite sides are parallel, diagonals are perpendicular, sides are perpendicular, and remember, parallel lines have the same slope and perpendicular lines have opposite reciprocal slopes. How do we prove parallelograms in the coordinate plane? So first we need to look at all of the properties that we know. These are the properties for a parallelogram, the extra special ones for a rhombus and rectangle, and then remember a square is a rhombus and rectangle together. So next we have to take a look at what formulas would give us each of these properties. We could use the slope formula 4 times to prove opposite sides are parallel, distance formula 4 times to prove that the opposite sides are congruent. It's not possible to prove that opposite angles are congruent. We could use the midpoint formula 2 times to prove diagonals bisect each other. And again, it's not possible to prove that consecutive angles are supplementary. Once you have proven that a quadrilateral is a parallelogram, next, let's move on to do a rhombus check. So if we use the distance formula on 2 consecutive sides, and they happen to be congruent, then that would actually prove that all 4 sides are congruent. We could also use the slope formula 2 times to prove that the diagonals are perpendicular. And again, it would not be possible to prove whether diagonals bisect opposite angles in the coordinate plane. In order to do a rectangle check, we could use the slope formula 2 times on 2 consecutive sides to prove that they're perpendicular, which means they would form a right angle. And then we could also use the distance formula 2 times to prove that the diagonals are congruent in a rectangle. So there are a lot of options for each specific type of parallelogram. So let's look at what's the fastest. In a parallelogram, using midpoint formula 2 times to find out that the diagonals bisect each other is the fastest. In a rhombus, using slope formula 2 times to find that the diagonals are perpendicular. And in a rectangle, using slope formula 2 times on 2 consecutive sides to prove that they are right angles would be the fastest. However, keep in mind that every time you prove whether a quadrilateral is a parallelogram, you have to do a rhombus and rectangle check, just to be as specific as possible. So instead of doing the midpoint formula 2 times, even though that's faster, I would suggest to use the slope formula 4 times, 1 on each side, so that doing that, you also take care of the 2 times you would have to calculate slope for the consecutive sides to do your rectangle check. So what happens if you took that first step for the parallelogram test, found the slope of all 4 sides, and it's not a parallelogram? What happens next? So first, let's talk about our options. We have a trapezoid, isosceles trapezoid, a kite, or just a generic quadrilateral. So here are all the special properties that we need to distinguish what is what. Next, we can look at the formulas. So because in that parallelogram check we would have already done the slope 4 times, if you have 1 pair of opposite sides parallel, you'll know it's a trapezoid. And if you have no sides parallel, you would jump down to your kite check. Okay, so let's say we found 1 pair of sides parallel. Then you would do an isosceles trapezoid check. You would have to use the distance formula 2 times, but you have options. You can either use it on the 2 non-parallel sides, the legs, to see if they're congruent, or you can use it on the diagonals to see if those are congruent. If you didn't have any parallel sides and you had a kite, you could use the distance formula 4 times to find 2 pairs of consecutive sides being congruent. Now the property that you have 1 pair of opposite angles congruent, you can't test for that. You also can't test to see that the non-congruent angles are bisected. Now, the diagonals are perpendicular, but specifically one of those diagonals has to be bisected. So in order to do that test, you would have to do the slope formula 2 times, the midpoint formula 1 time, and check to see that this midpoint is actually on the equation of the line for the other diagonal. So, with all these considered, these are the fastest ways to determine if it's going to be a trapezoid, isosceles trapezoid, or a kite. So it involves a lot of distance formula. And again, if we can't prove any of the special properties, then we would just say that this is a generic quadrilateral. So given these 4 coordinates, let's go ahead and classify the quadrilateral. The first thing I'm going to do is use this x and y axis just to help me sketch my quadrilateral. So here's point A, 1, -1, and then point B is about 5, -2, and then point C is 6, 1, so I'm going to put that about here, and then D is going to be 2, 2. So the sketch is really just to help you kind of visualize the quadrilateral to see where all the points are. This is not going to be accurate. We just want to know what we're finding sides of and what are the diagonals. So first, let's go ahead and get started by finding the slope of all 4 sides. So if I'm finding the slope of AB, then I'm going to take -1 plus 2 over 1 minus 5. So I'll get 1 over -4. And then the slope of BC is going to be 1 plus 2 over 6 minus 5 equals 3 over 1, which is just 3. Next, I'll find the slope of segment CD, and that's going to be 2 minus 1 over 2 minus 6, which gives us 1 over -4. So already we have 1 pair of opposite parallel sides. And then the last side, we have the slope of DA, which is going to be -1 minus 2 over 1 minus 2, which gives us -3 over -1, which -3 divided by -1 is actually a +3. Remember that? So now we have another pair of opposite parallel sides. So that means we definitely have ourselves a parallelogram. Let's go ahead and do our rectangle and rhombus checks. So for a rectangle, the fastest is going to be to take 2 consecutive sides and see if they are perpendicular, because if they are, that means they form a right angle, so then we would have ourselves a rectangle. So the diagram helps us to find the 2 consecutive sides. You can take any 2 consecutives. I'm just going to take AB and BC. So when we compare those slopes, the slope of segment AB, which is equal to 1 over -4, and then the slope of BC, which is 3 over 1, you can see that these are opposite but not reciprocal. So because these are opposite but not reciprocal, that means they are not perpendicular. So this is not a rectangle. So we can put a big X through the rectangle option. So lastly, we have to check whether this is a rhombus or not. So for the rhombus, the fastest check is to see if the diagonals are perpendicular. So again, diagonal would be DB and AC. Now unfortunately, we haven't taken the slopes of those yet, but that's okay. It's not going to be very hard. So we'll take the slope of segment DB, and that's going to be 2 plus 2 over 2 minus 5, which gives us 4 over -3. And then our other diagonal, which is going to be AC, that's going to be -1 minus 1 over 1 minus 6, and that gives us -2 over -5. So when we take a look at this, our slopes, and remember, -2 over -5, that's actually a +2 over 5. So again, we have opposite slopes, but not reciprocals. So these are not perpendicular, so this is definitely not a rhombus. So we can put an X through that. So our final answer, quadrilateral ABC, is a parallelogram. And that's it. Let's go ahead and work out another one together. So A is going to be at -2, 1, and again, we are just approximating to give us a visual. B is at 4, 3. C, we have 2, -3. And then D, we're going to have at -4, -5. So let's start with our parallelogram check, taking the slope of all 4 sides. So first we have side AB, which is going to be 1 minus 3 over -2 minus 4, which gives us -2 over -6, which simplifies to a +1/3. Then our next side, BC, is going to be 3 plus 3 over 4 minus 2, which gives us 6 over 2, which is a +3. And then we have the slope of CD, which is going to be -3 plus 5 over 2 plus 4, and that gives us 2 over 6, which simplifies to a +1/3. And then lastly, we have a D, which is going to be -5 minus 1 over -4 plus 2, and that's -6 over -2, which simplifies to a +3. So again, I went in order around the quadrilateral. It doesn't really matter where you start, but I just went consecutive sides so that it's much easier to see once I finish that, hey, these are opposite sides that are parallel. And we have another pair of opposite sides that are parallel. So we can definitely say that this is a parallelogram. Next, let's go ahead with our rectangle and rhombus check. So again, we want to check 2 consecutive sides to see if they form a right angle. So again, I'm just going to take AD and DC. Those are the ones that I chose from my diagram, and I'll take their slopes. So the slope of CD is 1/3, and the slope of DA is a +3. Now, these are reciprocals, but they are not opposite because they're both positive. So again, they are not perpendicular, which means that the sides do not form right angles, and so we do not have a rectangle. So lastly, we need to do our rhombus check, and that's going to be our diagonal, so we have to take AC and BD, and again, we don't have those slopes already calculated, but it won't take us very long. The slope of AC, that's going to be 1 plus 3 over -2 minus 2, which gives us 4 over -4, which is -1. And then the slope of DB, that's going to be 3 plus 5 over 4 plus 4, which is 8 over 8, which gives us a +1. So when you take a look at these two slopes, a -1, remember this is 1 over 1 and 1 over 1. So they are reciprocals. One is negative, one is positive, so they are opposites, which means that these slopes are perpendicular. So this is a rhombus. That is our final answer for quadrilateral ABCD. Now just remember, this quadrilateral is actually very close to being a square. When we did our rectangle check, we found that the consecutive sides were reciprocals but not opposite. If they had been opposite reciprocals and the sides were perpendicular and this was a rectangle and all of the rest was still true, this would actually be a square. Okay, let's walk through this next example. Point A is at -2, 1. So we'll go ahead and plot and label. Point B is -1, 4. Point C is going to be 2, 3. And then D is going to be 3, -4. So go ahead and look at your plotted points to give you an idea. And then we're going to go ahead and start by doing our parallelogram check. So that's slope of all 4 sides. So first, AB, we're going to have 4 minus 1 over -1 plus 2, which gives us 3 over 1, which simplifies to just 3. Side BC will have 3 minus 4 over 2 plus 1, which is -1 over 3, and that's already simplified. We have side CD, which is 3 plus 4 over 2 minus 3, which is 7 over -1. So already we can see that this pair of opposite sides is not parallel. So we have a chance that if this fourth side is parallel to BC, it could be a trapezoid. So let's find out. The slope of the last side, DA. This is -4 minus 1 over 3 plus 2, which is -5 over 5, and that gives us a -1. So we don't have any opposite sides that are parallel, so we have no opposite sides parallel. We do have this pair of sides that's perpendicular and they're consecutive, but that doesn't really tell us anything, just to have one pair of consecutive sides that are perpendicular. So it's just something to note if you notice the numbers, but it doesn't tell us anything. So if we have no opposite sides parallel, that means this is definitely not going to be a parallelogram. This is not going to be a rectangle, it's not going to be a rhombus, and it's not going to be a square. So what are the options we have left? And actually we have no opposite sides parallel, so we can also throw out trapezoid and also the isosceles trapezoid. So the only options we have left are kite or just a generic quadrilateral. So in order to do the kite check, we're going to need to take the distance of all 4 sides and see if the consecutive ones are congruent. So let's go ahead and do that. So first, let's find the length of segment AB. So we're going to pull out our distance formula. So here we have 4 minus 1 squared plus -1 plus 2 squared. This is going to simplify to 3 squared plus 1 squared, which is 9 plus 1, and that is the square root of 10. I would not simplify it. This one you can't, but I wouldn't even try because you're not going to need to. Next, let's go ahead with side BC. I'm going to write that out down here. We have 4 minus 3 squared plus -1 minus 2 squared. This gives us 1 squared plus -3 squared. This is the square root of 1 plus 9. So again, we're going to get the square root of 10. Now, AB and BC are consecutive sides since they both meet at point B. And since they are square root of 10 and square root of 10, we have one pair of consecutive sides congruent. So we just need to check the other pair of consecutive sides, and if they are congruent, then this is, by definition, a kite. So let's check that other pair. So AD, the length of this side, is going to be 1 plus 4 squared plus negative 2 minus 3 squared. This is going to give us 5 squared plus negative 5 squared. So that gives us 25 plus 25, which is going to equal the square root of 50. And then let's do the last one, which is going to be side CD. So here we have 3 plus 4 squared plus 2 minus 3 squared. This gives us 7 squared plus negative 1 squared. And this gives us 49 plus 1, which is also 50 squared. So since AD and CD are consecutive, we have another pair of consecutive congruent sides. So because we have two pairs of consecutive congruent sides, so on our diagram that means that AB and BC are congruent to each other, and then AD and CD are congruent to each other. So by definition, quadrilateral ABCD is a kite. And that is our final answer. I hope you were okay. I know it's a lot of algebra, but hopefully you followed along in our process of how to classify quadrilaterals on the coordinate plane. I'll see you in class for more practice.